Hi everybody, welcome back to the channel. What's new on the workbench? So I want to create a build video. The idea of this is to show everything from the beginning, from concept through to the end of the build, and if the wind ever dies down, I will show maidens of the different planes that I have. The winds are just too crazy, especially for something sub 250. The winds are just going to catch it and go all over the place, like we found out with the oldie and the crashes that happened there. So in this, what are we going to do? The idea is make 15 to 25 minute videos of the build process as it goes along. This way it's not too long. We're not doing a 2-3 hour video. You get little bits and pieces and you get to follow along as we go. So with this, what are we building? Well, we're going to build basically a flat jet or a delta wing. These are the plans that we're going to do. These are the electronics that we're going to use. So a 30 amp ESC. We're going to use 2 servos. We're going to use our 2-cell 450 amp LiPo battery. We're using the 60 gram 222 kV motor. We're going to use the FS IA6B receiver. This is going to be our control horn for the elevons. We're basically going to cut that in half and put it in. They work really, really well if you don't have the plastic control horns to put in. We are going to use something similar to this as a prop. We have not added this into the weight of it because we're going to get different props. So this is a 6-inch prop. The idea here is we're going to use a 5-inch prop. That way it clears in this area right here where it'll be sitting, such as this. Okay, so the 6-inch, a little too big. We want a 5-inch, take a little 1/2 inch off of that. It's going to work really, really well. So we'll take that out for that. So in this, again, we're doing a flat jet style delta wing design. And this is the basics of the designs. Now, most of these are done absolutely flat, a little bit of fuselage, sometimes a little piece underneath, kind of a T-style build with these. The idea here is to actually create something that's got some dimension, keeping it, again, under the 250 gram weight limit. So we've weighed our electronics. They are 151 grams altogether, not including the propeller, which again we'll add into that. I know that the 8-inch props that I use are 6 grams, so I'm assuming that a 5-inch should be somewhere in the 4 gram range. So we're looking at 155, which leaves us 95 grams to play with. The whole idea of this is to use 1 sheet of foam board. So that's the design. We know that the foam board is 30 inches by 20 inches. So what I've done in this whole design, this will be a foam piece that goes onto the end, a squishy foam piece of packing foam to protect, gives a little bit better. Of course, we'll cover that in some of the fiber tape. Makes it really, really strong. It'll probably just tape on as well as fitting into the fuselage. So with this, we have a cutout here that will be open for our prop. Our motor sets in here, and the propeller comes through. So it'll come through here and here. That's 5 inches from center. The motor will mount up in this area on the fuselage. Now, we're trying to do all very straight, flat pieces, nothing bent, nothing, well, things will get bent, but nothing rounded. So, elevons is the whole control surface of this. We're going to be mounting our servo somewhere in here on the side wall of this. So the idea is this is an intake that comes in. The fuselage will be triangular. So that will give plenty of open area, as you can see in here, for air to come in and travel through to the propeller. and then back down through the back, which will be another area which will condense down. Will it create extra thrust as it condenses down? Possibly. Everything's theory right now, and it may fly horribly, but we won't know till we put it all together. The cockpit here, cockpit cover, will be all angles, so it's going to give it a very stealth fighter-esque type of a look. We're going to put a fin down here to protect the propeller as it comes in for belly landings, as well as dual fins in the back. Whether they create any extra stability or not is yet to be seen, but the whole idea is that if this belly lands, the propeller, even in the full down position, will not contact the ground and therefore break. Broken propellers fly off. They do damage foam as it goes away and through. So the idea is to prevent that. Along with that, what we get with an upper wing running up here at the top of that fuselage and some weight down here is it doesn't become a center mounted wing. Most of the weight's down below, so it'll fly very similar in a lot of ways as a Piper Cub, keeping all that weight down low. So it should keep it very, very stable. As a flat flyer, of course, with no airfoil, they fly like they fly. You know, we could do a KF foil on it. I want to stay away from that kind of thing, trying to keep the weight down. So the idea of making this all out of one sheet of Dollar Tree foam board is, I know that one piece weighs 110 grams with the paper on. We take the paper off, we're down to 55 grams. So 55 plus 155 should put us at 210 grams. With, of course, we're not counting the foam that will be taken off, that we won't be using. We're probably going to be using some sort of carbon fiber spar in this area, being the weakest area because of the cutout, even though we are going to be doing sides down, which will help a lot with strength. This still becomes our weak area because it's very thin through here. So we're probably going to put a carbon fiber spar across that to help strengthen it. It might not be as short as this. It might go almost full length from here to here. Just not sure. We'll get into that when we go to the build video. So this is the basic idea. I do believe that, again, with this being triangular, from this point to here it angles down, which is really going to open this area up for air to come in, as well as coming out. With the flat little pieces under there, my hope is that it will create some sort of a wing style surface, right? It'll float because it'll be somewhat flat. We're gonna give it a little bit of an angle, dihedral. If it ends up being more like a wing like that, it should help with it flying. The other hope is with these two surfaces down here and this, it creates a type of a biplane type of a deal, where you're going to have the stability and lift of two wing surfaces. I do understand that these are angles, and that could create all sorts of different problems. I think the upward angle here compensates for that flat wing and might give it that upward lift. It's opposite of what a biplane has, which is, you know, one is angled and the other one's angled a little bit more. But we'll see. We'll see where it goes with everything. So this is the basics of it. Again, I'm going to take you step by step in short videos of the build process, what we do. So hopefully everybody enjoys it. I definitely will enjoy building this. I think it's a very unique design. I'll give you the basics. So from this point here, because we're not counting this, to this point, this is going to be 20 inches. So that is basically, if our sheet is like this, a foam board, this will be turned on its side to take the 20 inches up this way, leaving a lot there. So from here to here is 7.5 inches, 7.25 at the longest point, which will give us a 15-inch wingspan at the widest point. So that's going to take up half of the sheet. With this minus, of course, we will have all this to make other pieces, as well as another 15 by 20 inch to create all the rest of the little pieces. I estimate it to not take a full sheet to lay everything out, all the different pieces. So again, with the paper off, we're looking, you know, somewhere probably in the 50-gram range, which will be great. Adding some tape to give it some structure to handle stuff, especially down on these fins, covering some up here. That's going to add a little bit of weight, but at 55 grams, we still have 40 grams to play with before we even get in that realm of the 250 gram. I don't think we're going to get as close to it as we, so we have to worry about it. But this is the basics of it. All the electronics will go in here. The motor, as I said, will mount here. Real easy. The ESC will go in probably somewhere in here. The battery will figure out weight-wise where it needs to go, and of course the receiver will fit in also. So everything will fit nicely into this cockpit. That's why we've gone with the width that we've gone here, which is 3 inches across here, and we're 1.5 inches at the nose. So when we go to cut this whole thing, we'll cut here, down to here, across. This whole thing will be flat, and then cut the other wing surface. So that will be one solid piece. From there, instead of making a full triangle like this and attaching it up in, we're only going to make this triangle, and we'll glue that onto the bottom. That way this wing is the top part of that triangle. So we'll make marks as we do that, glue it all in, and go from there. So then we'll of course cut out a hatch that this cockpit cover will go and cover everything. Obviously it doesn't have to come out to here. We'll probably come down this way, down here, and make it about that big. That's plenty. We can reach all around in there to fill in any electronics. Obviously, you know, having that much covered. So it's a very small space that needs to get cut out. So structurally it should be very, very sound. Again, triangles being very, very strong structures. That fuselage will come out here, and this way we'll put a cover of foam on that. We will put on the motor mount the motor to that. As I said, the motor sits up high. It's not centered in this. It'll sit up high. And hopefully draw enough air down through. We're obviously going to have it sticking up at the top. It's perfectly fine as long as we don't land inverted. We should be fine. And even if we do, hopefully this piece right here and that will keep it so that if it does land inverted for whatever reason, again, the propeller is protected and we won't be breaking propellers. A lot of the planes that I've had, when they crash, of course the propellers break, and then you're stuck replacing propellers. And I mean, of course that's all part of flying, but when you have to keep replacing them because you're breaking them, then you have to keep ordering them and getting new ones in. So trying to think of ways to create planes that protect the propellers. That's, you know, something that saves us money in the hobby. You know, propellers will break. All sorts of things can happen. The idea is to create preventative measures so that we can protect them and not have to replace them as often. So this is the basic build. Again, We're going to do short little bits as we go along, and I'll post them as I go. I did not post a video yesterday because I have sinus problems, and with the weather changing the way it was, which is one of the reasons why we have such bad winds right now, I couldn't deal with the day. So here we are now. This is where we're at. We're going to go forward with this. If I ever do get a chance to beat the wind and do a maiden flight, of course, I will take the tripod out and we're going to give it a go with that if I can't find somebody to video for me. And we'll get what we get. It won't be the best video, of course, but it will be a video. And hopefully it shows enough that whether it flies or crashes, you'll get to see it. So this is the whole thing. I hope everybody's excited about it as I am. So go out there, go make it. You can do it, folks. Come up with a design, test it, see what happens. If it doesn't fly, change things, keep going, change the design if you need to, rebuild it again, and have a lot of fun. So until then, have a wonderful day.